Okay, so for now we'll discuss some application questions on changing binomial become normal distribution. Okay, so we can have a look for example 16. You can read the question first. Okay, so for question example 16, first part, the question is very kind because they already tell you that it is binomial distribution and mean is 11, variance is 45. Okay, and after that they want you to find the number of plants per box. Okay, so how can you get the number of plants per box? If it's binomial distribution, so you should have n and p, right? Okay, so here they tell you that mean is 11, which means for a binomial distribution, np will be equals to 11. Okay, and variance is 4.95. Therefore, variance is 4.95, which means npq is 4.95. Okay, then I want to solve simultaneous equation to get an answer. From first part, np is 11. Therefore, I should substitute np to 11. Therefore, 11q will be 4.95. So q is equals to 0.45. And p is 1 minus q, which is 0.55. And n, you can get it from the first equation again. Eventually, you will get n equals to 20. So n is the number of plants per box. Okay. Then now, for part number 2. Find the probability that a box contains exactly 12 plants which produce yellow flower. Okay, so that means for one single box, they have 20 plants in total, and they want to know probability that 12 plants produce yellow flower. So if you read the structure of the question, it is binomial distribution, right? Okay, so 20, p is 0.55. So they want you to calculate the probability for x equals to 12. Okay, so one question here, should you change this binomial become normal distribution or not? Okay, so you can check the condition yourself. First, is it n greater than 30 or not? No. For this case, n is equal to 20 only. So the condition is not fulfilled anymore. Therefore, you cannot change it become normal. So you remain it as binomial distribution. So use binomial formula to calculate the probability. So 20C12, 0.55 power 12, 0.45 power 8. Then from here, you will get the answer, which is 0.162. I will keep my answer in 3 significant figures. Okay, alright, so this is what we have for part B. So it doesn't mean that all the binomial you have to change it become normal. Before you want to change it, either you look at the keyword or either you check the condition yourself before you change. Okay, then now we have a look for part number 2. There's another shop sells the plant in the box of 100. So the shop's advertisement states the probability of any plant producing a pink flower is 0.3. So find the probability that contain fewer than 35 plants which produce pink flower. You are having 100 plants, fewer than 35 plants, something happened. So this structure of question belongs to binomial again. So it is still binomial distribution, and you are having 100. The probability that you put here should be something happened probability. So pink flower is something happened. So which is 0.3. Okay, and you can change it become normal distribution. Can you change it or not? So again, before you change it, you have to check first. First, check for n greater equals to 30. Okay, fulfilled. Secondly, check for n times p. So n times p, you get 30, which is already more than 5. Also fulfilled. The third one, you check for n times q. So n is 100, q is 0.7. You get 70, also more than 5. So all the 3 conditions fulfilled already. Therefore, you can change it become normal. So when you change it become normal, NP is 30, MPQ is 21. So maybe you can write beside lah. MP is what? MP is 100 times 0.3 equals to 30. MPQ is what? 100 times 0.3 times 0.7. So you'll get 21. So you just write it inside the normal distribution. Okay, then after you change it become normal already, so you want to answer the question now. So they are asking for y fewer than 35. Fewer, should I include the 35 or not? No equal sign, right? Okay, so there's no equal sign. So fewer than 35. So please take note that all these signs is very important, because if let's say you write the sign wrongly, then your continuity correction is wrong, then your answer for normal distribution also wrong. So this sign here, when you write out, please be careful. So fewer than, no equal sign. Okay, so less than 35. Okay, so this is binomial distribution. To change it become normal, you need to do continuity correction. So what is the value for continuity correction? Should it be 34.5 or is it 35.5? Okay, you can imagine and draw the graph. Okay, so if you do it correctly, the continuity correction should be 34.5. Okay, so binomial, you change it become normal. Then now to answer the question, we have to standard. So x change it become z. So 34.5 minus the mean divided by standard deviation. So I think the rest of the steps you should know how to do it already. Okay, so z smaller than 0.982 if I'm not mistaken. And you can get the answer straight away from the question, which is 837. If I correct it to 3 significant figures. Okay, this particular question, it involved binomial at first, and after that, the second part, they are having binomial and change it become normal. So exam question might look something like this. Right, so I hope that you have roughly have the idea. When do we need to change binomial become normal? You have to check the 3 conditions on your own. All right. Okay, then if no problem, then we continue to example 17. So the same thing happens here. Example 17, I might just want to roughly guide you how to do it, and then you try and see whether you can get the answer correctly or not. Okay, so now 8% of jars are defective. Okay, then 1 carton, there are 12 jars. So it supplies cartons of jars in crates of 60 cartons. So 1 crate got 60 cartons. So there are 2 different things. The first one is cartons with 12 jars, and then we have with 60 cartons. Okay, in each case, making clear the distribution that you are using, calculate the probability. Okay, so first, a carton contains exactly 2 defective jars. So for this one, we are talking about the number of jars, right? The number of jars. Therefore, in 1 carton, how many jars you have? 12. So out of the 12 jars, there are 2 jars, something happened. So again, if you look at the structure of the sentence or question, it is binomial distributed. So binomial, number of jars that you have is 12 in total, and then they want to have 2 defective jars. So the probability is defective. What's the percentage for defective? 8%. So 0.08. Okay, so what is the probability that they want you to count? They want you at x equals to 2. The number of jars is 2, so x equals to 2. Okay, so very obvious on this question, you no need to do binomial distribution. Sorry, you don't need to do continuity correction or change it become normal because n is small. The first condition is not fulfilled, definitely no need to change become normal. Okay, so this part I will just leave it for you. You just use the binomial formula to get the answer. It should be 0.13. Okay, then now we go to part number 2. Okay, so again, you are having 1 carton contains at least 1 defective jars. So again, we are still talking about the number of jars. Okay, so out of the 12 jars, there's at least 1 jar, something happened. So still binomial distribution. So the total number of jars that you have is 12, and then the defective is 0.08. So for this example, they want you to get the probability for x greater equals to 1. At least 1, right? So x greater equals to 1. Okay. Then again, notice it become normal distribution yet because the n is not more than 30, so cannot change. Okay. Then use binomial again to try and get the answer. So for this one, the answer that you get should be 0.6323336123. And of course, you cannot leave your answer like that. You have to change it become 3 significant figure, which is 0.632. Right, so this is what you have for part number 2. Okay, so the steps that I skip here, please make sure that you make it full. Okay, write down the proper steps here. Don't just leave it blank like this. Okay, then now you go to part number 3. Okay, so for part number 3, now they are talking about a crate, okay, contain between 39 and 44 inclusive cartons with at least one defective jar. So can you tell me now, what are they focused on? Are they still focused on number of jars or not? No, they are talking about cartons, 39 to 44 cartons. Alright, so when they are talking about the number of them, then maybe I will use the other variable, which is the y. X is the number of jars, so maybe that is the number of cartons. Okay, again, a crate got how many cartons? 60. So out of the 60 cartons, you have 39 to 44 cartons, something happened. So this is something happened. Okay, so again, binomial style, binomial distribution. You are having 60 cartons here, and then something happened. What's the problem for at least one defective jar? So you can see that these two questions are very similar. Okay, so what I have here is you should use the probability that you get just now and put it here, 0.632. Yeah, and if you look at this question itself, okay, n is more than 30. Okay, first condition fulfilled. Try NP. When you multiply these two values together, more than 5. Second condition fulfilled. You try NQ also more than 5. So the third condition fulfilled. It means for this question, you can change it become normal distribution. Okay, right. Then after that, what is the mean here? Mean is n times p, which is 37.9. If you change it, become 3 significant figure, and the variance is 13.9. Okay, so this is to how we write it out properly lah. Mean and variance. Mean is MP, variance is MP cubed. Okay, so now before you continue to get an answer, right? There's one thing that I want to remind you all here. Can you tell me that the 0.632? Okay, I cut it short, right? Because 0.632 originally is very long. Okay, so the 0.632 is the answer that I already cut it short. But in this example, because you still want to use the 0.632 in your calculation later, right? When you write it up, you can write it short like this at 0.632. But when you press the later, I will prefer you to use the long value. So the long value means that at least to 5 decimal places if you feel lazy, or 6. Okay, for me, usually I will use odd. But when I write it up, I write it out short in 3 significant figure. But when I do the real calculation, I'm pressing the whole value here. Alright, I understand it's a bit tedious because if we want to get the most accurate answer, then this is something that you should consider. Okay, right, so the same thing happened here. The 37.9 is the answer that I already cut short. The original value is 37.94001674. So if you feel so lazy to type in everything here, you at least must include 37.94002, okay, in your calculation. Then this one also the same. Okay, it should be 13.949 something. 9492689. Okay, so again, if in your calculation you're lazy to do so, then you can use 13.9493 or 94927. Okay, so all these are the answers that I cut short to 3 significant figures. But in the calculation part, you should include it as long as possible if you want to get the more accurate answer. Okay, then now I will continue with the question. So a crate contains the number of cartons which is between 39 to 44. Okay, all right, so how can I get 39 to 44? So this is for binomial distribution, and you need to change it become normal first. Okay, so how to change it become normal distribution? Okay, so again, 39 to 44 is included, so the continuity correction should be either minus or plus 0.5. So imagine the graph yourself. If you didn't do Taylor's mistake, you should have 38.5 to 44.5. Okay, and after that, again, change it become Z. So you have to standardize it, 38.5 minus the mean. What is the mean? 37.9 divided by standard deviation, square root 13.9. Okay, then again, 38.5 minus the mean divided by standard deviation. Okay, so again, when I write it out short, 37.9 and 13.9 only. But when I press the calculator, I will include the long value here. Okay, when I press the calculator, I will include the long value here. So again, it is a bit tedious, but for me, I want it to be safe. Therefore, I usually do it like that. Okay, then after you get the answer, you can keep it to 3 significant figures already. Right, so if I'm not mistaken, 3 decimal places. So this one should be 0.150 and this should be 1.756. Okay, then continue from here, try to get the answer and value from the table. You should able to get 0.4008 as the answer. If you want to change it become 3 significant figure, then it will be 0.401. Okay, so this is what we have for this question. So a bit tedious, but just make sure that you know the small details that you should take note. Yeah, so the steps here, just go and fill it up. What is the proper steps that you should write out? Don't skip practice. Make it as a practice so that you know how to write out correctly. Okay? Alright, then the very last example. Okay, so sometimes they will also include the two-stage questions by using binomial and normal. Maybe, so that's why when we introduce this part, a lot of students, they will find, wow, the question become a bit more complicated already. Okay? Right, so we can have a look here. So first they talk about the weights, X grams. So X is gram, the weight of soap, which is normally distributed. So again, if originally it is normal, they will sure tell you the keyword one, normally distributed. Mean is 125, standard deviation is 4.2. Find the probability that the soap weighs more than 128. So they are talking about the weights, right, for first part. Therefore, originally, again, it is normal distribution. Okay, so I will just write X is normally distributed. What is the mean? 125. Standard deviation is 4.2, and then you square it. Okay, so for this particular question, you want to find X greater than 128. So no need to do any continuity correction or whatsoever because originally it is already normal one. So there's no continuity correction needed. Okay, then change it becomes Z straight away. Okay, so you write out the standardized pattern, standardized formula, and then the steps here and so on, should be able to get 0.2377. And if you want, you can change it become 0.238. Alright, so again, complete this part first before you continue. Alright, so this question, part number 1, is fully about normal distribution. Yeah, right. Then now, so first part, they are talking about the weight of bar soap. Okay, then if part number 2, calculate probability that all of the 2 selected bar soap weigh more than 128. Okay, so now you are having 2 soap here. The first one is more than 128. The second one also more than 128. So 2 bar soap here is a complete case. Okay, so first bar soap is 0.23, is more than 128, right? Maybe I write out like this. So for the first bar soap, first one, the weight is more than 128. The second one is also weight more than 128. So one question here, should I put multiply or should I put the plus? Okay, so here they said 2 bar soap. So 2 bar soap is a set, one complete set. So to make the set complete, you have to multiply that. So which means you should have 0.2377. Use the original value from normal table, multiply with 0.2377, and you should be able to get 0.0565. If you change it, become 3 significant figure. Okay, so this one, nothing special. It is just a very normal type of probability. Okay, then now we continue to the third part. Now you are having 5 bar soap, and then there are more than 2 of the soap weight more than 128. Okay, so if you look at this question, 5 bar soap, more than 2 soap, something happened. So from the structure of the question, what is it about? It will be a binomial distribution. So maybe y is the number of soap. X is the weight, right? So I don't want to use the x anymore. I will use y. Y is the number of soap. Therefore, originally it is binomial distribution. Distributed 5 soap in total, and they want to calculate the probability for 2 of them, more than 2 of them, weight more than 128. So the something happened is weight more than 128. So what is the probability for this something happened? So you get it just now. Okay, so you should put in 0.2377. So please put in the original value. Don't use a shortcut. Don't put 238. You should put 2377. Okay, and after that, they want you to calculate the probability number of soap more than 2. Okay, so more than 2 means that start from 3 or 3, 4, and 5. Y equals to 3, Y equals to 4, Y equals to 5. By using binomial, for this question, you don't need to change it become normal. So by using binomial, I will not show you the steps. You go and complete it yourself. This answer should be 0.0910. Okay, so when they started to introduce all the normal and binomial distribution together, right, you have to be very, very skillful in finding out which part of the question is belongs to binomial. That is very important. I told you since chapter 4, right? So to identify the binomial question, usually you need some small techniques. So make sure that you have this skill in exam. Okay? Alright, so this is what we have for all our syllabus in statistics, AS statistics. Again, the same thing I want to tell you is all the examples here are very limited. So that means it is not enough for you to score very high in exam. So if you want to score high and learn up, okay, and all the skills, all the technique that you learn in all these syllabus here, you have to really try a lot of puzzle questions or a lot of questions. Okay, Alright, so this is what we have for our AS test papers. Okay, then I think it's time for you to prepare for your final exam already. So your final exam will include everything. Okay, so just make sure that you go and figure out what you need to focus on. Right, so that's all for the video today. Thank you very much.